Hello students, I am Ms. Pooja Kalange, Assistant Professor IICMR NCA. Welcome you to this video lecture on inventory management. Today we will be covering the model number 1 where we have the inventory model or the EOQ model with uniform demand with no shortage. So before I begin with this topic, I would just like to brush up some important concepts for those who are not attending the lectures or would have missed out the lectures. So basically, what is EOQ? EOQ is said to be as the economic order quantity. Okay, so it is a inventory problem in which the demand is fixed and known, and it is always referred to be economic order quantity. So here we have a uniform demand, and so it is the economic order quantity. So you know that demand is nothing but the number of units which are required, and lead time is the time gap between placing the order and receiving the order. Then we have the order cycle. Order cycle is the time period between two successive orders. So with this a bit of prerequisite, we'll start with our model number 1. That is the EOQ model with a uniform demand and with no shortage. Okay. So basically we'll see what are the variables which we'll be using while solving the problem. This chapter is based on the you should know that how the variables are to be identified and what are the formulas to solve these problems. In this PDF at the last I have given you a comparative chart of how to remember all the formulas for each and every model, so that will surely help you in practicing the problems based on this unit. Okay, so basically capital D will be the demand. CS stands for the setup cost. Now see, the book which I have referred has used these variables. You can change the variable as the way you're studying from any which book. Since I've referred the Hira Gupta book, I'm using these variables. Okay, so C1 refers to the ordering cost, carrying cost, and the holding cost. So any of these will be termed to be as C1. I stands for inventory carrying cost. You can say just a plain C stands for the unit price, and C1, that is ordering cost, is multiplication of inventory carrying cost into unit price, that is IC. So this is a bit important formula. Next we need to know is average inventory is just you have to have the maximum inventory plus minimum inventory divided by 2. So that is said to be Q, which is the order quantity. So now we'll see the basic formulas in this. So the total inventory is total inventory carrying cost plus the total ordering cost, which is given as C of Q is equal to 1 by 2 QC1 plus D by Q CS. Q stands for the quantity of ordering, C1 stands for the setup or order, sorry, it's for the ordering, purchasing or holding cost. D stands for the demand, Q as the same order quantity, and CS stands for the setup cost. Now the important formula, very important, optimum EOQQ0 is equal to under root 2 CSD divided by C1, where C1 is equal to IC. T0 is Q0 by D, N0 is D by Q0. T stands for time interval, N stands for number of order or frequency, and the minimum total annual inventory cost is equal to C of Q0 equals to under root 2 CS C1D. This is C of Q0, another important formula, and minimum yearly total cost CT is equal to C of Q0 plus DC. Okay, so these are some important formulas you need to know before you solve these problems on model number 1. So let's see the problem. An aircraft company uses nut bolt at an approximate rate of 2500 kg per year. Each unit costs rupees 30. It costs rupees 130 to place an order, and inventory carrying cost is 10%. Determine optimum size of each order and how frequently the order should be placed. So if you see here, 2500 is nothing but the demand, which stands for capital D. Now the unit price is given by C, that is the rupees 30. Now it cost 130 to place the order. So this stands for the placing cost, or the placing order cost is given by variable CS. Okay. And the inventory carrying cost, that is I, is 10%, that is 0.1. So these are the variables which are already given to you. So if you see here, I've already written here D is equal to 2500 kg per year. C is 30 rupees. I will be 10 divided by 100, that is 0.10. So we can calculate C1. C1 is I into C, that is 30 into 0.1, that is 3 rupees. And the CS is considered to be as 30 rupees. Okay. So if you get jumbled in using this cost, you just remember C1 stands for IC, that is inventory carrying cost, and this is the purchase cost. So the next cost which is given in the problem can be considered as the setup cost. Okay. So the formula, as you know, it is being asked here to find out what is the optimum size, that is you have to find out the EOQ, and how frequently means you need to find out the number of the orders to be placed. So basically EOQ formula, you know, under root 2D CS upon C1. So 2 into D is 2500 into setup cost 130 upon C1, that is 3. So this gives you 465.47 units. So the time period will be first Q0 by D, that is 465.47 divided by 2500, that is 0.186 per year. If it is asked in months, you need to convert it into months. And number of order which needs to be placed here is N0D by Q0, that is 2500 divided by 465.47, that is 5.37 orders per year. So I hope you are clear with this model number 1 of inventory carrying cost. In this PDF, I have attached one more problem. You can just practice this problem also. I'll just may give you the PDF also. And if any queries, you please let me know. Thank you for watching this video.